Episode 12: Viral Evolution Under Ribavirin Pressure, Quasispecies and Mutagenesis. Welcome back to Ribavirin Reminiscence and Lingering Load in Long COVID-19. I'm your host Anushka, a genomics explorer who spent years mapping the intricate tapestries of life's genetic code. Today, we are plunging into a concept as thrilling as it is contentious. Can ribavirin, like a cunning saboteur, push a virus to mutate so recklessly that it collapses under its own chaos? This strategy, known as lethal mutagenesis, might hold the key to tackling viral persistence in long COVID, where hidden reservoirs could be stoking chronic symptoms. Joining us is Saakshi, a master's student in microbiology whose sharp insights into the microbial world illuminate the shadows of virology. Saakshi, welcome to the show.
Thanks, Anushka. I'm thrilled to dive into this. Lethal mutagenesis is one of ribavirin's most intriguing effects, but it's also one of the most misunderstood.
Let's lay the groundwork. Picture a quasi-species as a bustling swarm of viral variants, each slightly different, like a kaleidoscope of genetic possibilities. Sakshi, what exactly are quasi-species and why are they a big deal for RNA viruses like SARS-CoV-2?
That's a vivid image, Anushka. A quasi-species is indeed a dynamic cloud of related viral variants, each with subtle genetic differences coexisting within a host. RNA viruses like SARS-CoV-2 are notorious for their rapid and error-prone replication. This sloppiness churns out mutations at a breakneck pace, hence creating a diverse population where some variants fizzle out and others gain ground. Its evolution is on fast-forward basis. Quasi-species give RNA viruses incredible adaptability, hence allowing them to dodge immune responses, resist drugs, or even thrive in new host environments. For SARS-CoV-2, this diversity is a survival superpower, but it might also be a vulnerability we can exploit.
So, where does ribavirin enter this chaotic dance? If quasi-species are a swarm, is ribavirin like a storm that disrupts their rhythm? Summarizing, we are exploring how ribavirin turns the virus's own replication against it. Sakshi, how does this work?
Exactly, Anushka. Ribavirin is a nucleoside analog, a molecular mimic that sneaks into the viral replication process by posing as an RNA building block. But it's a saboteur. It introduces errors into the viral genome during the process of replication, like typos in a critical blueprint. At high concentrations, these errors pile up, overwhelming the virus's ability to produce functional genomes. This triggers an error catastrophe or lethal mutagenesis, where the viral population collapses under the weight of too many defective variants. Instead of a few strong survivors, the entire swarm implodes.
This sounds like a brilliant trap, but does it actually spring in real life? To summarize, we are asking if lethal mutagenesis is a lab fantasy or a proven weapon. Sakshi, what is the evidence for this with other viruses?
It's very real, but context matters. Lethal mutagenesis has been demonstrated in several RNA viruses, such as poliovirus, where ribavirin pushes mutation rates beyond survival. Another is Lassa virus, with similar error-driven collapse. And in hepatitis C virus 2, though the effect is partial due to resistance mechanisms. And even influenza in lab models show susceptibility. The catch is that it's dose dependent and virus specific. Not every virus falls for ribavirin's trickery, and the threshold for catastrophe varies. It's like trying to overload a system. You need just the right pressure to crash it without letting it adapt.
Now, let's zero in on our target. If SARS-CoV-2 is the elusive quarry, can ribavirin force it into this mutagenic meltdown? Summarizing, we are probing whether ribavirin can outwit this particular virus. Saakshi, what do we know?
That's the $1 million question, Anushka. In vitro studies show ribavirin increases the mutational load in SARS-CoV-2, piling up error in its genome. But whether this triggers a full collapse, that is unclear. A major hurdle is SARS-CoV-2's proofreading enzyme, a rare feature among RNA viruses. This enzyme acts like a copy editor, catching some of ribavirin's induced errors, which dampens the mutagenic effect. To achieve lethal mutagenesis, you would likely need very high ribavirin doses, potentially too high to be safe in case of humans. So, while the concept holds promise, it's not a straightforward win against SARS-CoV-2.
Let's connect this to long COVID, where viral remnants might be lingering like embers fueling a chronic fire. Could ribavirin's mutagenic push extinguish these smoldering reservoirs? Sakshi, what's the potential here?
It's a tantalizing possibility, especially in tissues like the gut or lymphoid organs, where viral fragments or low level replication might persist. In these slower, compromised reservoirs, ribavirin could theoretically tip the quasi-species into extinction by amplifying errors. But it's all about hitting the sweet spot. Intracellular concentrations must be high enough to drive lethal mutagenesis without being sublethal. If the dose is too low, you risk nudging the virus toward resistance, creating tougher variants. Delivery and dosing are the linchpins for long COVID applications.
This feels like wielding a blade that could either slay the dragon or cut the wielder. Could ribavirin's mutagenesis backfire, creating a more dangerous viral spot? Summarizing, we are exploring the risks of this high stakes strategy. Sakshi, what's the danger?
You nailed it, Anushka. Ribavirin's mutagenic pressure is a double-edged sword. At low levels, it might increase viral diversity without killing the population, like stirring a hornet's nest. This could spawn more evasive or resistant variants, which is the last thing that we want. Precision is critical. Too little pressure risks fueling viral evolution, while too much could be toxic to the host. That's why ribavirin demands careful, context-specific use guided by rigorous data.
As we peer into the fog of what's next, what research could light the way? If ribavirin's potential is a locked vault, what keys do we need to unlock it? Sakshi, what studies would you love to see?
We definitely need to close the knowledge gap with targeted research, like sequencing studies in long COVID patients treated with ribavirin, comparing mutation patterns before and after to map its mutagenic impact. Another could be in vitro persistence models of SARS-CoV-2 under ribavirin pressure in order to pinpoint the exact threshold for lethal mutagenesis, and animal models mimicking chronic low-level viral persistence in order to test ribavirin's efficacy in reservoir-like conditions. These studies would definitely help us tune ribavirin's use, ensuring it's a weapon and not a wild card.
Sakshi, Thank you for navigating this virological maze with us. You have shown that ribavirin isn't just a blunt antiviral. It might turn a virus's own evolutionary speed into its downfall, like a trap that uses the enemy's momentum against it.
Absolutely, Anushka. It's a brilliant strategy. But like all bold plans, it's fraught with risks and unknowns.
So next time on ribavirin reminiscence and lingering load in long COVID-19, we'll explore how we can identify who might benefit most from ribavirin's unique powers. Until then, I am Anushka. Stay curious and remember, sometimes the best way to defeat a virus is to let it outsmart itself.